Zoe and Claire, the science pair. Zoe and Claire, the science pair. Go, 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 go. Gene expression. Science rules. Zoe and Claire, the science pair.
Hey, nice jeans!
Thanks. Got them from my mom.
On today's episode of Zoe and Claire the Science Pair, we will be learning about gene expression. But what does gene expression have anything to do with denim?
Well, technically, nothing at all. Gene expression has to do with DNA, RNA, and two processes we call transcription and translation.
This process begins with DNA. DNA codes for specific genes using bases in a structure like this, called a double helix.
What kind of bases are they? Like baseball bases?
Not quite.
Well, then what are they?
I'm glad you asked. These bases in DNA are nitrogenous. They consist of adenine, or A, thymine, or T, guanine, or G, cytosine, or C. These bases go together like peanut butter and jelly. A pairs with T, and C pairs with G. DNA codes for certain proteins to be made. A group of 3 bases is called a triplet. The triplet codes for specific amino acids. The only issue with DNA is it does not fit through the small pores of the nucleus.
That's right, Zoe. This is where RNA comes into play. RNA is similar to DNA, but like with 2 months on Weight Watchers. RNA is single-stranded, no double helix, and does not have base pairings. Thymine does not exist in RNA. It is replaced with U or uracil. It's still like the yummy peanut butter and jelly sandwich, but now A and U are peanut butter and honey and work together just the same, but are not as original.
3 types of RNA.
Here I have the transcription model of science. We know that DNA needs to become RNA to leave the cell, but how does it happen? It starts with RNA polymerase, an enzyme whose job is to create RNA by reading the DNA coding strands. As you can see, the RNA polymerase moves along the strand of DNA reading the bases on the coding strands. It pulls in the RNA bases floating in the nucleus and pairs them with the corresponding base in the DNA.
This isn't the end.
It isn't? I feel like I've been here for ages.
This process is very fast, Claire. Your cells are creating 20 amino acids per second. All these parts are working really hard.
Well, so am I. What's next?
Splicing. The enzyme used in this step is called SNRPs or spliceosomes. They are like the cut function on your computer. Now, the RNA is mature RNA.
When the mRNA comes close to the 2 subunits of the ribosome, large and small, they sandwich the mRNA and the protein making begins. Once the mRNA is sandwiched in the ribosome, it reads the codon to see what amino acid needs to be used. The ribosome pulls the tRNA with the correct anticodon, which is the opposite of codon, into the A site of the ribosome. tRNA moves to the P site to deposit its amino acid. The tRNA then leave the ribosomes via the E site. The ribosomes continue to read the codons of the mRNA and match them with anticodons until a protein is formed and complete.